Alrighty class, it's time to begin our next lesson. Today we'll be looking at section 5.5, using similar figures. Now, I really do hope that you have finished that worksheet you had for homework, that worksheet where you had to, solve proportions and tell whether the things are proportional. Remember, it had 10 questions on it. Hope you've done that. If you haven't, you need to do it. Some of you might have already finished it in class, and that's great, but if you didn't finish it in class and you had to take it home to finish it, make sure it's done. All right, let's get started. So using similar figures. The reason why I wanted to put the homework is because we have to use proportions to solve similar figures, okay? Listen to what I'm saying. Don't just focus on writing stuff down. Listen to what I'm saying. You have to use proportions to figure out these similar figures. And here's how it works. We gotta copy down this. 2, gotta put an O right here, but the word 2 polygons are similar figures if, okay? So we have 2 polygons, and they are similar figures if a few conditions are met. And these are the conditions. First condition is the corresponding angles have the same measure. If the corresponding angles have the same measure, and if the lengths of the corresponding sides form equivalent ratios. Remember, if they form equivalent ratios, they're proportional to each other. So that's what we're going to do. So corresponding angles and corresponding sides. You might be wondering, what does corresponding mean? Well, I'll show you. And you might be wondering what a polygon is. A polygon is any 3 or more sided shape. So you could say it's a shape, but it can't be an oval or a square or a cone or a heart. It can't be anything like that. But any shape that has 3 or more sides to it is a polygon, okay? All right, here we have 2 trapezoids, okay? This is our example 1. And the corresponding angles, it's like this upper right angle corresponds to this upper right angle on the second trapezoid. The lower right angle corresponds to the lower right angle on the trapezoid. This green angle corresponds to this green angle, while this red angle corresponds to this angle. So I'll go ahead and tell you that for the purposes of what we're doing, these are equal to each other. Like this angle is equal to this angle. The green is equal to the green. The red is equal to the red. And of course, the right angle, that's what that little symbol means. The little box right there means that's a right angle. It's equal to 90 degrees. Okay, so all of that to say that these are corresponding sides. So we can look at the angles and say, okay, all the corresponding angles, they match up. The whole length, though, part we gotta take a look at. The length of the corresponding sides form equivalent ratios. So let's take a look at what that might be talking about. Well, what it's talking about is, well, here we have different sides, and corresponding sides form proportional ratios. So for instance, let's take the smaller side and put it at top of our ratio. So I have 8, okay? And I'm going to compare that to 12, because that's a corresponding side. You see how it's on the top and that's on the top, okay? Now, next we could say it should be equal to, because it says equivalent ratios, equal ratios, to another pair of corresponding sides. So pick another pair of corresponding sides. We could pick 10 and 15. So we pick 10 and 15. Now please remember that you can cross multiply. You can cross multiply to find out if they're equal to each other, or you could reduce. If we reduce these fractions, what do we get? Well, for 8 and 12, 4 goes into both of them. So we could divide this by, we could divide it by 4, and we would end up with 2 and 3. You could divide this one by 5, and you would get 2 and 3. You see that? That happens with all similar figures. And you might be wondering, well, what's the point of using similar figures? They come in real handy because if you ever are drawing maps or you're making a model for something you might be doing, like if you're in film or you're making model cars or you need to make a smaller representation of something, it needs to be done to what they call, it needs to be done to scale. You wouldn't want, like for instance, if you draw a person, let's say you took like one of your classmates and you wanted to draw them proportionally where they actually looked like a person, you wouldn't go and make their head huge like that while making their body only that big, would you? That doesn't make sense. Nobody's head is that big compared to a body that small. You can't find a real person like that, sorry. You can draw a little stick figure person like that, and you're not going to have like, one arm super long and the other arm really short. Okay, and he's got like a really big thumb, but then his other fingers are really tiny, and then he's got like a foot right there, and then his other leg goes down like that. Like that guy is totally not drawn proportional. Okay, he's drawn all out of whack. Okay, so drawn proportionally would be like if you made them look exactly the same. But he'd be on a piece of paper, so he'd be a lot smaller than he would be in real life, but you could still tell who it was because it's drawn proportionally, okay? Okay, let's get on to our next example. All right, in this example, it's basically told to find the value of x and y is what we're told to do. So we're going to be told to find the value of x and y. And for these types of problems, you will be told that they are equal, okay? That they are equal to each other, that they are proportional to each other, that these shapes are similar figures. If you're told any of those things, then that means that the corresponding sides form equivalent ratios. So you should be able to find the missing thing. Well, how? Well, this is what we're going to do. First, you need to identify at least one corresponding pair that contains two numbers. So a corresponding pair that contains two numbers without a variable. Well, if you look at this side, this is the straight up and down side, so the y and the 32, the 32 and the y, they correspond. This is the lower half of our triangle. It corresponds to the 5 over here, while the 12 right here corresponds to our 3 right here. 12 to 3, that would be our one that doesn't have a variable. So let's make our fraction. Once again, I will use the smaller on top, which is easier that way for me. So put your 3 divided by 12, okay? 3 divided by 12, and that is going to be equal to, and what we do is we just take care of one side at a time. So let's find x first because it comes first in the alphabet. And before you go and just put x wherever you want, you need to ask yourself, where is x? Is it on the big shape or the small shape? Which one is it? On the big one. Where did we put the big number for ours over here? On the bottom. So put x on the bottom also, okay? So basically your big shapes are on the bottom, small one on the top, okay? That's the one thing you don't want to do, make that mistake. Find x's corresponding side on the small, which is 5, okay? And now we just cross multiply and get our answer. So you would cross multiply and you would say, well, 3x is equal to 60, and then you would divide by 3 both sides, and you would get x is equal to, well, what's 60 divided by 3? It should be 20. So x is equal to 20, okay? So basically the same set of skills we use to solve proportions we're going to use today. The only difference is we have to write the proportion. So we have to be able to look at the shape and write the proportion and then solve it. That's all we have to do now. Let's finish this up. So over here we're told to find y. Once again, locate your corresponding sides that just have numbers. So we have 3 over the 12 is equal to, put your bar, we got to put our y. Does that go on top or bottom? Where does it go? It goes right here, okay? So what corresponds with y? 32, okay? You cross multiply. Remember, I told you if you wanted to, you could reduce first if you wanted to. You didn't have to, but if you want to reduce first, you can. If you reduce this first, you would get 1 over 4 is equal to y over 32. Now cross multiply, and you would get 4y is equal to 32. You would divide both sides by 4, and that would get us y is equal to, what would that be? 8. So y is equal to 8. So those are our two answers right there. We have x is equal to 20, y is equal to 8, okay? So that's all we're going to be doing. We're going to be looking at some shapes. We're going to see if they're proportional. We'll also see in class how you can take this type of math and plug it into real-world problems in order to solve. All right, so come to class prepared to ask questions. See you then. Bye.